Sir, in last two classes, we discussed about machine learning, the predictive models, and difference between machine learning and neural networks and deep learning. These things we discussed. Okay. So actually, today agenda to step into that generative AI. Before that, generative AI reinforcement learning understanding very required. Okay. So, but today it may be to do festival, very less people attended. So that's why I can about reinforcement learning topic I will come tomorrow. So today, as part of the machine learning, about one predictive model we have seen, which is the regression y equal to x dot w. Okay. So in this predictive equation, what is that x? X is the input matrix. As per machine learning terminology, we call it as feature matrix. And y is output matrix. In machine learning terminology, we call it as label matrix. So as per the given data, we know x and we know y. So first step, we need to prepare input matrix. That means the feature matrix. And next step, second step is label matrix. But as per what is the mathematics behind this to find out this W? W is a weight matrix, which constructs a relationship between features and labels. How to find out mathematically? We will see. W is a weight matrix. That means which contains bias and slopes of each input variable. So finally, this weight matrix constructs a relationship between features and labels. Okay. So then how to find out this W? Mathematically. Observe the data set. Suppose given data, same bold example I am taking, like day before day, we discussed about three input variables, one target variable. A is weight, height, okay, are input variables, and cholesterol is target variable. Think that the data has like this: age, weight, height, and cholesterol. Suppose given data, so first person and weight is 55 and height 6.1, cholesterol percentage 30. And 26, 90, 5.6, his cholesterol is 80. Think that in this way, they have given you 1,000 patients data to you. I'm taking the last patient. His cholesterol, let's say 90. In this way, the given data. Okay. So here actually mathematically, as per linear regression, y equal to mx plus c, which is a straight line equation. Got it? But here x is input variable, only one input variable in this example. So statistically, what you call it is, we call it as W0 plus W1 into x. So in this equation, x is input variable, y is target variable. This W0 bias or intercept, you can say. The W1 is slope of that input variable. But here, input variable is not one, input variables are multiple. Okay. So in this case, the equation will be like this: y is equal to W0 plus W1 into x1. Think that x1 is the age, value of the age. W1 is slope of age. Okay. So let's keep it cholesterol equal to W0 plus W10 plus W1 into A's value plus W2 into weight plus W3 into height. So three input variables, one bias. Finally, the W0, W1, W2, W3, these are the weights. These weights are constructing relationship between cholesterol and A's weight height. So once if I'm able to find out these weights, next onwards, if I know patient's age, weight, height, I can predict their cholesterol. Got it. But in this data, okay, there are only three input variables. Maybe in other data, there might be 100 input variables also. Got it. That's why I would like to write this equation for every given data line. So let's consider the first line. The line is like this. The cholesterol 30. How 30 is formed? Because of W0 plus W1 into the first person age is 20 plus W2 into first person weight 55 plus W3 into height 6 point. Okay. So in this equation, I know person's input details, person output detail, but I don't know weights. We need to find out those weights. So that's why I would like to form this equation in a generic shape. Let's say this Y1 I am saying. Y1 means target value of first person. That means first record. W0 plus W1 into X1. First row, first column. X11 I am saying. Plus, let me extend this. W2 into first row, second column. That means second input variable. Plus W3 into first row, third column. In this way, Wn first row, nth column. Got it. In a generic shape, we rewrite the same equation. Because data to data, the number of variables will be changed. That's why in a generic shape, we have written this one. And come to the second record. Second record target variable value, y2 equal to. Same thing I am constructing, W0 plus W1 into X 2, 1. That means second row, first column. Plus W2 into second row, second column. Plus W3 into second row, third column. In this way, so on. Wn into X second row, nth column. In this way, think that you have m rows. Okay, that's why ym equal to W0 plus W1 into X m1 plus W2 into X m2. In this way, the last Wn into X mn. That means m row, n column. Like this. This is what like the basic generic shape. Now this basic generic shape, I want to convert into matrix notation. Okay. Over here, the step one, converting into matrix notation in a linear algebra style. So in linear algebra, mostly we use matrices. The computations are based on the matrices. That's why we are converting this into the matrix. Even in our Python programming also, we implement the same thing in matrix notations only. Okay. Observe here. Left side, I am keeping something for matrix. Entire equal to left side, equal to right side. Okay. Left side one matrix. Left side of the equal to target values are there. Y1, Y2, Y3. In this way, I have m rows. That's why in the last, yn. Based on this, what is the size of this matrix? How many rows I have? M rows. How many columns I have? One column. M rows, one column. Okay, this is size of this label matrix. After that, equal to. Right side of the equal to, this expression is available. This entire expression available. But if you look into this entire expression, what are the known values? You know, age, height, weight, that means input variable values. But what we don't know? We don't know W0, W1, W2, these weights we don't know. As per linear algebra mathematics technique, whatever the things you don't know, whatever the things you want to find out, first you need to extract them. So that's why I'm forming them as a two matrices. I'm extracting W0, keeping it out. Because I don't know what is W0, we need to find out. So whatever the things you want to find out, first extract them out. And the same way, W1, W2, W3, up to WN. All these are the weights. Got it. Come on, sir. But if W0 extracted out, what is there here in the left side? If W0 came out, 1 is here. Look into the second expression, W1 dot X11. If W1 came out, what is pending? X1 is only available. Similarly, for the next, W2 came out, that's why X12. In this way, look into the last expression in the first line. Wn came out, so that what is pending here? X1, n is pending. Similarly, I'm forming the same second line. Again, in the second line, the first expression is W0, that's why here 1. So this is the reason in the beginning day of discussing about machine learning, we prepare one matrix. In that matrix, we kept the first column as ones. Because if W0 came out, 1 is pending. Got it. Do the same thing for the second row. What is here? W1 came out, so that X21 here. After that, W2 came out, the X22 here. Similarly, in the last, Wn came out, X2n is here. Similarly, the last row, which is M row, 1, XM1, XM2, XMN. Got it? Like this. Totally, as per this example, how many rows here? M rows. That means M observations. As per statistics, we call the rows as observations. How many columns I have? How many variables, input variables? N input variables. So because of M rows, my output matrix, the label matrix, has M by 1. M rows, 1 column. So based on this, in the right side, there are two matrices, multiplication is there. If you really matrix multiplication, what is the style of matrix multiplication? First row with first column of second. So like this, 1 into W0 plus X11 into W1 plus X12 into W2 plus, like this. Finally, if you multiply these two matrices, the above equation only you will get it. Okay. So here, what is the size of this matrix here? There are two matrices are involved. Left side one matrix, right side one matrix in the right part of the equal. Here, how many rows I have? M rows. How many columns I have? Tell me, please. How many columns I have? Here. Anyone, please try. N variables, but first column extra ones, right? That's why how many columns in the matrix? N plus 1 columns. N plus 1 columns. Got it. Similarly, here, what is the size of this matrix, W matrix? How many rows I have? N plus 1 rows. Because M input variable, n slopes, W1, W2, W3, Wn. But W0 is a bias is extra, right? That's why n plus 1 columns. Sorry, n plus 1 rows, 1 column. Got it. So we converted this basic linear equation into a matrix notation. Just if you try to apply a label for them, for these matrices. For example, for this matrix, I am giving a label called Y. Capital Y I am using equal to. And for this matrix, I am treating this as this matrix. I apply a symbol for this, which is capital X. After that, dot means matrix multiplication. And next, for this entire weights, I am applying one more symbol, that is W. This is W. Now, what is your final equation? Y equal to X dot W. Got it? So Y mathematically, we call that predictive equation as Y equal to X dot W. This is the reason. Got it. Now come to this, how to find out this W, that is the next challenge. Observe this one, Y equal to X dot W. So what is the size of this X? As per previous, I have M rows, N plus 1 columns. Size of Y, M rows, 1 column. Size of W, N plus 1 rows, 1 column. Got it. So we need to find out this W. Very simple mathematics here. Observe here, Y equal to 2X. Then what is X? What is the value of X? Y equal to 2X. Then what is X? X equal to Y. This is for normal scalar values, but not for the matrices, because in the matrix, there is no divided by. So that's why you cannot say W is equal to Y divided by X. Got it? So to find out this W, our challenge is we know X, we know Y value, but our challenge is to find out this W. To find out that W, you need to move this X into this left side, opposite side. Okay. So observe here, no need of strong mathematics here, a simple 8th standard, 9th standard mathematics, basic mathematics, that is enough to understand this one. To find out this W, you need to move this X into this side. Whenever X move to that side, X will become X inverse. X becomes X inverse. Got it? Suppose if I try to make this as X inverse, what happens? Just observe. X, I'm using the inverse symbol, that's a minus 1. Take that minus 1 is for X inverse. Got it? This is a wrong expression. What is the reason? What are the rules for the matrix inversion? Sir, anyone please? What are the rules for matrix inversion? First of all, matrix should be square matrix. And a determinant or det should not be 0. That is second rule. But here, if you observe the size of the X, I have M rows, N plus 1 columns. Square matrix means number of rows, number of columns, both should be equal. Number of rows, number of columns, both should be equal. But here, both are not equal. That's why X is not a square matrix. For example, you have 1000 patients and the 3 input variables, age, weight, height. That is N. N plus 1 means 4. Because first column you are keeping as ones. 1000 rows, 4 columns. Got it? It's not a square matrix. Similarly, here, what is the size of Y? 1000 rows, and 1 column. And what about W? 4 rows, 1 column. But look into X. X is not a square matrix here. That's why you cannot find out inversion. Okay. So here mathematically one more technique you apply. For example, A is a matrix. Matrix size is 2 by 3. Okay. Then what about A transpose? A transpose. Rows as columns, columns as rows. Then this will become 3 by 2. Okay. If you multiply any matrix with its transpose, so 3 by 2 dot 2 by 3, you will get a 3 by 3. If any matrix is multiplied with its transpose, you will get a square matrix. Whenever you got a square matrix, you can find out matrix inversion. So that's why here, small modification we are doing. Our equation is y equal to x dot w. In both sides, I will multiply this with its transpose. Let's say xt for transpose. Okay. But in the right side, I multiply to balance this. In the left side also, I am multiplying. Next. Now this part is a square matrix. This part is a square matrix. Got it. In both left and right side, we multiplied with x transpose. Finally, our target is to bring this expression into the opposite side. Now you can bring this into the opposite side. Now what will happen? Whenever it moves to that side, that will become inversion. Okay. So let's keep that expression here. X transpose dot x. For this entire expression, we need inversion. We need matrix inversion. Okay. Let me keep in a brackets. X transpose dot x into x whole inverse. Already you have in the right left side x transpose dot y. X transpose dot. It's not x, it's x transpose. This is another expression. Finally, we got the. Now let's reverse this entire thing. W equal to sorry. Let me keep this. Now what size we are expecting for this? N plus 1 by N. Let's tally this whether this equation correct or not to find out this W. Let's verify. As per our previous size of x, m rows, n plus 1 columns, correct? Size of y, m by 1. Size of w, how much we got previously? N plus 1 rows, 1 column. So if I compute with this expression, the same size should be coming. Okay. So just to verify this, size of x transpose. If x size is m by n plus 1, what is the size of x transpose? Reverse it. N plus 1 by Then size of X, M by N plus 1. To apply the matrix multiplication, what is the rule? Number of columns of right side, left side, number of rows of right side should be equal. Okay. Check here. Here number of columns M, here number of rows M, tallied. So that matrix multiplication is possible. Now final result is what? N plus 1 by N plus 1. That is the result here. Only for the left side expression. N plus 1 by N plus. Similarly, find out the right side expression. Only for the right part. The X transpose size is N plus 1 by M. Y size M by 1. Again, number of rows, number of columns, number of rows matched. Final result N plus 1 by 1. N plus 1 by 1. So this is the result of left side expression. This is the result of right side expression. Again, here also to apply these two matrix multiplication, number of columns, number of rows matched. Now final result is what? N plus 1 by N plus 1 by. Same thing we got it right here. So that means this formula is correct. To find out that W, to find out the relationship between two, that means input variables and output variable, this formula we will use. Okay, to find out statistically. So let's come to our patient's example. We have 1,000 patients. 3 input variables. The 3 input variables, what we have taken: age, weight, height. And 1 output variable, which is a label. Okay, that is cholesterol. For this, at the time of preparing matrix, the size of X, 1,000 patients. N plus 1. N is in number of input variables. N value 3, 3 plus 1, 4. That Y size, 1,000 patients. One target column, which is cholesterol. That's why 1,000 by 4. Then what about how much should be the weight matrix? 4 rows, 1 column. That means 1 bias, 3 slopes. Slope of age, slope of weight, slope of height, like this. Okay. So try to apply in the same formula. So whether we will get 4 by 1 or not, we will tally. Observe this. This is our W formula. Exactly 4 by 1 we should get it. Just try to tally this. Size of X transpose 4 by 1,000. X size 1,000 by 4. What is the result? 4 by 1,000 dot 1,000 by 4 means what we will get? 4 by 4 we will. Okay. Come to the right side part. Again, size of X transpose 4 by 1,000. Size of Y 1,000 by 1. Again, these two matrix multiplication result. Again, number of columns, number of rows matched. The result will be 4 by 1. Left side expression 4 by 4, right side expression 4 by 1. Again, number of columns, number of rows are matched. Now final result. The final result will be 4 by 1. Got it? So here also it is 4 by 1. So by using this formula, you can find out the relationship between input variables and output variables. Okay. So actually today agenda, I would like to discuss about reinforcement learning, which is a major prerequisite for the generative AI. But the people less attendance today due to Republic Day. So that's why a little background, mathematical background of this machine learning predictive model I have. Tomorrow we will discuss about reinforcement. Okay. So tomorrow if possible, some little time extra because Saturday, if all people are okay, some little time extra we will spend for this. Okay, sir, all of you, let's meet tomorrow.